happening is this. If my tap is closed, if the base is closed, no fluid is going to flow. Okay? So no base means no collector. Do you see that? No IB means no IC. What's that saying? If there is no base current, there is no collector current. That's like having the tap closed. Small IB means large IC. Everybody see that? So I open it up a little bit. I open up the tap a little bit, and I'm going to have a large current of the collector current that's going to now flow. So so what we'll do is we'll show a little IB here, and we'll show IC here. So do you see how the small IB is going to combine with the IC, and you'll end up with IE here, which is IB plus IC. This is how a transistor works. You've got base, which is your tap, which controls the flow of current from the collector side to the emitter side, and a little bit of IB will cause a large IC, and then the IC will combine with the IB and become I. That's in a nutshell how all transistors work. Okay, so let's look at figure 8. Let's look at figure 8. Figure 8 is a typical NPN transistor circuit. So I take this transistor here and I hook it up in a circuit. What kind of a circuit am I going to hook it up in? It's going to have two voltages. A voltage on the base side and a voltage on the collector side. So, why do I need the voltage on the base side? Because that's going to supply the base current. So this guy supplies the base current based on the value of RB, okay? So you've got this circuit here, which is going to supply base current, and that base current will then cause a collector current to flow in the other circuit. And where's the current coming from the collector side? From another supply called VCC. VDB provides the current on the base side. VCC provides the current on the collector side. And the two are going to combine into a value IE, which is what we're saying here. IE is IB plus IC. Everybody see that? So, that's a typical NPN circuit. What do you think is going to happen in the PNP? Everything is going to be opposite. So what I will do in figure 9 is I will change the polarity of my voltages. So let's look at figure 9 now. Figure 9 is the same kind of a circuit, but now the polarity of the base voltage is minus plus instead of plus minus, and the polarity of the collector voltage is minus plus instead of plus minus. So as far as the current is flowing in this circuit, it's from the plus to the minus. So there's IB, just like we showed here, IB. So that IB is going to be split from this IE, which is going to split into IB and IC. So the polarity here is going to determine the flow of the current in this circuit, and the polarity here is going to determine the flow of current in the other circuit. Okay? So with a transistor, think of the fact that you need two circuits. There's a circuit on the base side and a circuit on the collector side, and it's the base side which controls the amount of current that's going to flow on the other side. So it's like two separate circuits. Okay, so back to the faucet analogy. You've got base that controls the amount of collector current, and just a tiny amount of this will produce a large collector current, and the two will combine into the emitter current. Next page. So IE is equal to IB plus IC, as we said, and whether it is an NPN or a PNP. Okay, look at the two. Here's the first one. IE is IB plus IC. In this case, it's the same. IE is equal to IB plus IC. So whether it's NPN or PNP, the same equation applies for both. The current in the emitter is equal to the sum of the current in the base and the collector. What did we say about the size of IB? Very, very small. So if this is small and this is large, then we can say that IC is approximately equal to IE because IB is small. If this is 1 and this is 100, what is 1 plus 100? 101. 101. So 100 and 101 are about the same, is what we're saying. Okay, so that brings us to this example. So let's do the example.